everyone, and thanks for watching Edupedia World videos. This is the second video on the unit of linear programming, and we studied the theory the last time, and in this video we'll see a few different types of problems to familiarize ourselves with the concepts. So we discussed three types of linear programming problems at the end of the previous video: manufacturing, diet, and transportation problems, and we also did one type of question on manufacturing problems. So let's do another. So this is a manufacturing problem. So let's say a factory produces two models of a car, A and B. A requires 9 hours for fabricating and 1 hour for finishing. And B requires 12 hours for fabricating and 3 hours for finishing. The company makes a profit of rupees 8,000 on model A and 12,000 on model B, right? And what we need to do is maximize the profit. So let's say we have X amount of cars A and Y amount of cars B. So Z, which is the objective function, will be the maximum profit. That will be 8,000 X plus 12,000 Y. We need to maximize this. Now we are also given constraints in the question. The constraints are that for fabricating and finishing, the maximum hours available are 180 and 30. So you only have a maximum of 180 fabricating hours. What that means is 9 hours for each car, so 9x plus 12 for each car B, 12y, has to be less than equal to 180. And we are also given that for finishing, the total number of hours available are 30. So it has to be done in less than 30 hours. That means 1 hour for finishing X plus 3 hours for finishing B, that is 3y. And this has to be less than equal to 30. And obviously X greater than equal to 0, Y greater than equal to 0. We will assume this even when it's not given, because in this case it's quite obvious the number of cars has to be greater than 0. So we've converted a manufacturing problem that was a word problem into a basic linear programming problem, and now we easily know how to solve something like this. The first step to do is to draw the graph, right? So actually what I'll do before that is simplify these equations a little bit. This equation actually can be simplified if we divided it by 3 everywhere. So this would give me 3x plus 4y, and this 180 divided by 3 would be 20. So let's draw the graph. Now my graph will generally obviously not be drawn to scale, but you can draw it using a ruler yourself if you want to draw it to scale. So x greater than 0, y greater than 0 simply gives me directly the first quadrant, right? The other two constraints will give me two other equations. So 3x plus 4y less than 20. So that equation would turn out to be something like this. I made a minor mistake. This isn't 20, this is 60. 180 divided by 3 is 60. Yeah, so 3x plus 4y less than equal to 60. It would be something like this. When x is 0, y is 15. So this point is 15. When y is 0, x is 20. So this point is 20. Then you have x plus 3y less than 30. When x is 0, y is 10. So 10. And when y is 0, x is 30. So 30. So the other line passes through these 2 points. So what is our region of interest? This is our region of interest. Now once again, this is the region of interest because we have less than equal to. If this was x plus 3y greater than equal to 30, then we would have to take the right half plane, and then this would have been our region of interest, right? So take care of this equality properly. So right now this is our region of interest. We know this coordinate, this coordinate, this coordinate. Let's calculate this coordinate. 3x plus 4y is equal to 60. X plus 3y is equal to 30. Just multiply this by 3. So 3x plus 9y is equal to 90. Subtract from the first. We get 5y is equal to 30, which gives me y is equal to 6. If y is 6, 3y is 18. So x is 12. So this is 12, 6. And now we can just calculate the value of z for all of them. So at the origin it would be 0. At the point 0, 10, x is 0 and y is 10. So we have 12,000 into 10. At 20, 0, we have x is 20, y is 0. So 20 into 8 is 160,000. And we have the point 12, 6, where if you try to calculate the value, it will come out to be 168,000. So out of these four, 0 is the minimum value, so that's the minimum value of z, and 168,000 is the maximum value, so that is the maximum value of z, which means we should create a total of 12 cars of model A and 6 cars of model B. Let's look at another type of problem now. Let's look at a diet problem. So let's say that somebody needs to develop a special diet using two foods, P and Q. And P contains 12 units of calcium, 4 of iron, and 6 of cholesterol, and 6 of vitamin A. Similarly, Q is given to have 3 units of calcium, 20 units of iron, 4 units of cholesterol, and 3 units of vitamin A. And we are given some constraints. The first is the total diet requires at least 240 units of calcium, 460 units of iron, and 300 units of cholesterol. So what we need to do is we need to minimize the units of vitamin A, right? So we pick a certain number of units of P, certain number of units of Q, and we need to minimize the amount of vitamin A in the diet. So let's say you take this to be X and this to be Y in terms of the quantities. So calcium has to be at least 240. That means 12x plus 3y has to be greater than equal to 240. Now notice that this is a greater than equal to, not a less than equal to, which we've had in the before. Similarly, at least 460 units of iron. So 4x plus 20y has to be greater than equal to 460. Similarly, 6x plus 4y has to be less than equal to 300. I misread the question. At least these two, I'm sorry. And cholesterol is given to us to be at most, because we want less cholesterol. So here we have a less than equal to. So this is a nice question because we actually will be able to look at the equality signs as well. What we need to do is we need to minimize the amount of vitamin A. That means Z is equal to 6x plus 3y needs to be minimized subject to these constraints. So now we know what to do. We simply draw the graph. So I'll just rub all the unnecessary amount. We've just converted a word problem or a diet problem into a simple mathematical linear programming problem. Now it's best to first of all simplify the equations a little bit. So this equation basically comes out to be, so 12x plus 3y basically will give me 4x plus y, and this will be divided by 3, so 80. So 4x plus y greater than equal to 80. Similarly, you divide this by 4, you get x plus 5y. And 460 divided by 4 is 115. And this you can just divide by 2, so you have 3x plus 2y less than equal to 150. So these are the three equations. Now we start to draw them on the graph. Of course, x greater than 0 and y greater than 0 is assumed. So 4x plus y is equal to 80. When y is 0, x is equal to 20. So this is the point 20. and when x is 0, y is equal to 80. So let's say this is the point 80. So this would be the first line. Yeah. Then x plus 5y greater than equal to first. Okay, now it's a greater than sign, so we need to look at which direction it falls on, right? So any point here will have a smaller value of x and y. Any point here will have a greater value of x and y. So we are looking at the right hand side of this plane, right? That's important. We've already studied equalities in mathematics, right? Now if x plus 5y greater than equal to 15, when y is 0, x is 115, and when x is 0, y is 115 divided by 15, 115 divided by 5, that would be 23. So let's say this is 23. So this is the other point. And once again, it has to be greater than 115, so we need the right hand side of this point as well. So this is the region which we are looking at right now. And then you have 3x plus 2y less than 150. When y is 0, x is 50. And when x is 0, y is 75. So we have this sort of equation, but now it's less than, so we need it to be on the left of this line. So when you try to see properly, I suggest you do it on your own if you have a little bit of confusion. This is basically the region of interest. This is the region of interest which is towards the right of the first two lines, but towards the left of the second line because we add a less than equal to. Well, it's a triangle and we need to be able to calculate the 3 points. So let's do that. So let's write the equations of the lines first. This is going through 80 and 50. Sorry, this is 75. This is going through 80 and 20. So this is 4x plus y is equal to 80. This is 3x plus 2y equals 150. And this line is x plus 5y equals 115. So points of intersection. For this, we need to intersect the first two lines. 4x plus y is equal to 80. 3x plus 2y is equal to 150. Let's say this is multiplied by 2. 8x plus 2y is equal to 160. Subtract 5x is equal to 10. X is equal to 2, which gives me from this equation 4x is 8, so y is 72. So this point is 2, 72. Now I'll not solve the other 2 points, you can just do it yourself. This is 15, 20, and this point is 40, 15. And then you calculate the value of z is equal to 6x plus 3y at all these points A, B, and C. And what we see is at 2, 72, z comes out to be 228. At the point 15, 20, it comes out to be 150, and at 40, 15, it comes out to be 285. So this is the minimum and this is the maximum. Now in this question we were asked to minimize the value of vitamin A, so we would take B, which means we would take 15 packets of P and 20 packets of Q. If we had to maximize vitamin A, we would take C, which means, we would take C, which means 40 packets of P and 15 packets of Q. Let's look at one final problem, and this will be the third type of problem, a transportation problem. So let's say we have an aeroplane carrying a maximum of 200 passengers, and they need to be divided into two classes. Let's say A and B, the economy class and the executive class. So a profit of 1000 is made on the executive class, while a profit of rupees 600 is made on the economy class. But the constraints are given, we need at least 20 seats for the executive class. So if this is x and this is y, the first constraint is that x has to be greater than or equal to 20. Then we are given at least 4 times as many passengers prefer to travel by economy than by executive. That means y has to be greater than or equal to 4x. Another way of writing this would be y minus 4x greater than or equal to 0. Right. So what we need to do is basically maximize the total profit. That will be z is equal to 1000x plus 600y, and these are the two constraints that are given to us. Obviously x greater than or equal to 0, y greater than or equal to 0 is always understood. So we'll just draw the figure first. X greater than or equal to 20 would be the plane to the right of this. Y greater than or equal to 4x. So y is equal to 4x means the slope is 4. So it would be something like this. For y greater than 4x, we need the outside of this. So the region is above this line and towards the right of this line. So this is the total region. And another thing which you are given is the plane can carry a maximum of 200 passengers, which means x plus y has to be less than or equal to 200. So let's just, this is 20. So this is 20, 80. Now we need x to be 200 and then we need y to be 200. It will be something like this. This will be the line. And you know what? I'll just draw the figure a little bit better because it will be hard to see with this scale. So I'll just draw the figure out of scale to make it seem clearer to you. So let's say this is x is equal to 20. So this is the line x is greater than or equal to 20. This is the line y is greater than or equal to 4x. So we need the left of this line and the right of this line. So this is the region. And then we have this is, let's say, 200. This is also 200. So then we'll have a line like this. So this is the total region. This line is x plus y is equal to 200. This is y is equal to 4x. And this is x is equal to 20. So first x is equal to 20, y is equal to 4x gives me 20, 80. And then what is this point? X is equal to 20, x plus y is 200. So this is 20, 180. Clearly this figure isn't drawn to scale. And for this point, we'll need to get x plus y is 200 and y is equal to 4x. So 5x is equal to 200 means x is equal to 40, y is equal to 160. So this point is 40, 160. And this is the region we are talking about. So let's calculate the value of z at all the three extreme points. Let's say this is A, B and C. Then at A the value of z is 20 into 1000, so 20,000 plus 180 into 600, so 18 into 6 into 1000. So 108,000 and 20,000, 128,000. At B we have 40 and 60, so we have 40,000, 40 and 160, sorry, 40,000 plus 160 into this, so 16 into 6 into 1000. So 96,000 and 40,000, 136,000. And at C we have 20 and 80, so 20,000 plus 8 into 6 into 1000, 48,000, that is 68,000. So we can easily see that the maximum amount of profit is created on option B, which means we should have 40 executive class tickets and 160 economy class tickets, and that would give me a profit of 166,000 rupees. So this completes linear programming. In the next video, we'll begin the last and final unit for 12th class mathematics, and that will be called probability. Thank you.